All right, a little bit of logs, a little bit of exponentials here at the end just to get us back. We are going to look for an exact value for this problem. And since we only have an exponent on one side, we can just go ahead and start by taking the log or ln of both sides. Since I see ln's in my answers, I'm going to go ahead and take the ln of both sides and start. I'm going to use ln. With this problem, it doesn't matter which you use. If you use log, you would just have to know that ln would give you an equivalent answer as long as you did the same thing to both sides. So here, when I take the ln of 2 to the x, or 2 to the 3x minus 1, I have to make sure I do that to the other side as well. And that allows me to pull down that exponent. I'm just going to take a look at my answers over here. It looks like I have ln of 2 in one of them in the denominator. So I'm going to go ahead and divide both sides by ln of 2. Your other option here, if you didn't want to divide at that point, is to multiply the ln of 2 into the parentheses, and then you would divide by it later. I think this is the possibly true here, and I think it's going to matter. Okay, so I'm left with 3x minus 1 on the left side of my equation, and ln of 5 over ln of 2. Now I'm just solving for x. I'm going to add 1 to both sides. And now to get x all by itself, I need to divide by 3. But if I look at my answers, 3 of them have this 1/3 out front. And multiplying by 1/3 is the same as dividing by 3. So I'm going to write it like that with all of those solutions in mind. Or if you even wanted to write, instead of that, divide by 3 times 1/3 on the left side as well. That would be lovely. So I have 1/3 on the outside, ln of 5 over ln of 2 plus if you weren't wanting to do the algebra and you were just wanting to guess and test, you could take all of these values, put them in for x, and put into your calculator 2 to the 3 times, 1/3, whatever, minus 1 equal, and hit enter. And when the one that gives you 5 is going to be the right answer, you would get D doing that as well. So you can do that. You can solve that by guess and test. For me, I think it would take, if I didn't guess right in the beginning, it would probably take me longer to put those kind of messy equations into my calculator. 2 more problems. Given the graph below, what is the period of the function? Well, when we're doing sine or cosine, the period of the function is usually 2 pi, but here I'm only getting one kind of half of the period in 2 pi units. For sine, we need the kind of below the x-axis part, the down part of the wave, and the up part of the wave both. So from negative 2 pi to 2 pi, that number of units is 4 pi units. This is a horizontal stretch by a factor of 2. So the period of the function is 4 pi. Last problem. What's the y-intercept of negative sine of 2 times x minus pi over 2 minus 1? So this guy is a little misleading. Those parentheses there, I think, would be helpful. I'm just going to go ahead and talk through what this would look like. So this is all factored out. If you liked doing the period, or the phase shift is c over b, you need to multiply that 2 back in. So if you liked that rule that the phase shift is c over b, you've got to multiply that 2 back in. So it'd be 2x, and then 2 times pi over 2 is pi. And you could do C over B. C over B then is pi over 2. They give it to you in factored form to make your life easier. So this factored form gives you the phase shift there. If you don't like looking at that, again, if you like the rule that we use, we always just did C over B, you've got to multiply that 2 back in. Just recognize this form is a little different than your So what's the y-intercept? So for sine, again, these little graphs really help me. This is a reflection over the x-axis. So we would start our sine graph just down and then up. With the 2 in front here, the 2 here is going to make this a horizontal shrink by 1/2. Or the way we dealt with that in the context of trig graphs, is we said usually our period is 2 pi. We do 2 pi divided by the number in front of x to give us the period of the function. So the period of this function is pi. So that makes this pi over 2. If we're going to move, here our phase shift is minus pi over 2. So if we're going to deal with this minus pi over 2, this is pi over 2 to the right. So we would pick this whole graph up, maybe do a little bit more graph would be helpful here, and move it pi over 2 to the right. But before we do that, we have to go back and check our last transformation that I totally almost missed, which is this minus 1. That's a down 1. So instead of all of this happening centered around the x-axis, this whole mess is happening move down 1 unit. So let's take this graph. Let's move it down 1 unit. So it's my same pattern. I'm just going to recopy here. Down and then up. Other way, up and then down. And then I need to pick it up and move it pi over 2 to the right. Well, what that's going to do here is that's going to move this place right here where we're crossing our midline. It's going to take that guy and move it. I was hoping to pick the whole curve up together, but it's going to shift this whole thing right pi over 2. And so, where is our y-intercept? Our y-intercept is right here at -1. Now, trig graphing is going to be on the calculator portion of your test. So that kind of problem is definitely something that you could double check on your calculator or put into your graphing calculator, make it look exactly like that equation does, and go on to play. You guys want to start out, especially, I definitely wasn't going to phone it in on the very last problem. I hope these videos have been helpful. Good luck on the exam.